Okay, this is example 1 on page 48 of your book, and I'm gonna do examples 1 through 3. I think they're very good examples. So I just want to go. I mean, you can go ahead and read it in your book if you'd like, but I just wanted to maybe just input some intermediate steps if that's helpful. Okay, so it says solve the initial value problem, and we're given dy dx, right? That's our y prime, minus y equals 11/8 e to the negative x over 3. And we're also given our initial condition, right, since it's an initial value problem. Y of 0 equals -1. Okay, so here's our IVP, right, our initial value problem. And in this section, right, so this is a first order linear differential equation, right, because the derivative, the highest derivative is the first derivative. And in this section, we are going to use Theorem 1 in your book, which is on page 50. And Theorem 1 has a special form, and so the special form is so dy dx plus p of x y equals q of x, and then of course you're given an initial condition, and I want you to notice that this is exactly what we have. We have a differential equation, right? We have a certain p of x and q of x, which I'll point out in just a bit specifically, and then our x naught and y naught, right? Here's our x naught and here's our y naught. So this first order linear differential equation has a unique solution, right, on some given interval. And so in this section, we're going to use 3 steps to solve this differential equation. So let's go ahead and start. So let me move this just a little bit higher. Okay, so the method is we're going to use, again, 3 steps. And the first is going to be, we're going to begin by calculating an integrating factor. And actually we are going to do the integrating factor, but I do want to point out, so what is our p of x and q of x in our problem? Well, our p of x is actually the function in front of y, which is really just a constant function. It's -1. And this guy is my q of x. So if we write that out, so my, let's see, well, we'll write it in green. So my p of x is going to be -1, and my q of x is going to be 11/8 e to the negative x over 3, right? So they're both functions of x. So it's not necessarily 1, but that's what you're doing in the beginning. You have to determine what your p of x and q of x are. Okay, so now number 1 is we want to calculate. So I'm just following the steps on page 47. This, I think, is one of the questions in your concept questions. What are the 3 steps to solve this differential equation? So we're going to calculate the integrating factor. So integrating factor, which is called rho of x, right, is equal to e, and we're going to integrate, that should be a rho, not a p, looks like a p, rho of x dx. Okay, so let's go ahead and integrate that. So we have rho of x equals e to the, well, what is my p of x? That's just -1. So e raised to the -1, right? That happens to be my p of x dx. And this is a pretty easy integral, right? The integral of -1 dx is just, so e to the negative x, right? That is what our rho of x is. So that is our integrating factor. And the next step is we're going to multiply this integrating factor to both sides of our differential equation. So step 2 is, so I'm going to multiply e to the x to, let's see, we'll just say left-hand side and right-hand side of our dE, our differential equation. So if we go ahead and do that, we get, and let's see, so we can see the differential equation. Okay, so we have e to the negative x, right, times dy dx minus y equals e to the negative x times 11/8 e to the negative x over 3. Okay, so there's my integrating factor that I multiplied to both sides of the equation. And so if we go ahead and just kind of multiply this e to the negative x in to the equation, or to our expression, we get the following. Okay, so I'm literally just distributive property. E to the negative x times dy dx plus e to the negative x times y. And let's see, this guy is not too bad. This is just 11/8. And just for now, I'll go ahead and leave these two guys. Okay, so what do we notice about this left-hand side of the equation, right? This should remind you of something. This is actually the derivative, right, of e to the negative xy, right? If we use the product rule, right, this is a product of functions, we're actually going to get this, right? That's the definition. So we want to rewrite it like this for now. You'll see why in just a bit, or maybe you already recognize it, which is fine. And then this is just simple algebra, right? We have the same base, so we're going to add our exponents, right? So that's -1 and -1 and -1/3, which is just really -4/3, or negative 4x over 3 after simplifying. So another thing I wanted to point out is, so the book has a notation, right? This ddx, another way of writing it is dx of your row of x, right? In this case, ours is e to the negative x, but we can just write row of x, right, times y of x. This is always going to be true. And let's see, just to be consistent, I think I said my e to the x was this light green, right? That's going to be a row of x times yx. So that's all it means. Okay, so now that we have this, we recognize this derivative of a product function, or product functions, we can definitely integrate. So, and my step here, let me just go ahead and write. So here was, we recognized, right, that was a product, the derivative of e to the negative x and y. So now moving on to step 4 is we want to integrate. And my integration, let's see, okay, so I'll go ahead and write the problem again. So we have ddx of e to the negative xy is equal to 11/8. Oops, that's negative 4x over 3. And so now we want to integrate, and let's see, let me use, I don't know, this light blue. So I want to integrate both sides of this equation, and we want to integrate because we have a derivative, and so the inverse operation of this derivative is the integral. So we know this is going to be gone, which is great because we want e to the negative xy. And then we can even take out this 11/8. It's just a constant, and we are going to integrate this guy with respect to dx. Okay, so let's just continue, make this a little bit smaller. Okay, so we still have e to the negative xy just kind of hanging out on the left-hand side. So we want to integrate this guy. So the 11/8, again, is just my constant outside. And I want you to recall, let's see, let's choose yellow. Okay, so this guy looks like e to the kx, right? And when we integrate e to the kx, right, our integral is going to be e to the kx, and then we're going to divide it by our constant. And then, of course, our constant of integration, which is right there. Okay, so that's what I'm going to use. So I have e to the negative 4/3 x, right? It's another way of writing it. And I'm going to divide it by my k, which in this case is negative 4/3, right? Plus my constant of integration. And then this guy, we just keep writing for now. But again, when you divide by a fraction, that's just multiplying by the reciprocal. My exponential function stays the same. I still have my constant of integration. And this is the same. And then again, if we multiply these fractions, right, we get negative 33 over 32 e to the negative 4/3 x, plus, if I want to distribute the 11/8 to c, we can write 11/8 c, but we can just write c. It's some constant. Again, if you want to let k be 11/8 of c, that's perfectly fine. Okay, so next step. And so remember what our goal is. Our goal is to solve this differential equation, right? So we want to find a function y of x. Well, oops, here is our y, right? Or y of x that we want. So how do I isolate y? Well, we could multiply both sides by, let's see, let me choose a different color. I don't know, let's do orange. So I can multiply both sides by e to the x. So I'll go ahead and write it right here. Why? Because e to the x times e to the negative x is e to the 0, and e to the 0 is just 1. 1 times y is just y, right? Or y of x. So y of x is equal to, negative 33 over 32, right? And here I just have the same base, so I'm adding negative 4/3 x plus 1x, or negative 4/3 x plus 3/3 x, which is negative 1/3, negative 1/3 of x. So again, I'm just adding fractions. 1/3, let me actually rewrite that as, I'll just make it easier here. I'll just write it as negative x over 3. Okay, that doesn't look nice. Negative x over 3. So that is our solution, right? This is a general solution, right? Because we still have our constant c. But since this was an initial value problem, we have to use our x naught and y naught and our recall. So we're almost done. So remember that our initial condition, right, y of 0 was negative 1, right? That's our x naught, and that's our y naught. So let's go ahead and substitute these values so we can find the desired particular solution. So substitution, let's see, y of 0, and we like when x is 0. 0 over 3 plus c, that's negative 1. Well, e to the 0 is just going to be 1. So we're just left with this guy. And then, of course, if we just solve for c, right, that's negative 1 plus 33 over 32, or you can rewrite this as negative 32, oops, it's only one negative, negative 32 over 32 plus 33 over 32. And then finally, we get 1 over 32. So that's our constant. And so now we can substitute that back. So we have y of x equals negative 33 over 32 e to the negative 4/3 of x, or we can write it like that if you'd like, plus our constant. And so, and if you notice in your book, the answer is different. They just factored out a 1 over 32 If you do, great. If you don't, it's okay.